Drop a one in the chat if you are having a good week. Perfect, perfect, perfect. Got some people having good weeks here. Not a good day today, Melissa. I'm so sorry to hear that. Well, I hope your day gets better. Definitely something that we always want people to have good days. All right. We're sending data. All right, we are good. Let me pull up the chat here for Restream. Span this out to another window so I can see the chat for Restream. Let me get my presentation pulled up. And we are about to go live. All right, we are live. We are live on YouTube. We are live on Legendary Academy. We are live on Facebook across a couple channels. And unfortunately, LinkedIn isn't letting me live stream. So if anyone knows how to live stream on LinkedIn, greatly appreciated if you could help me out with that. Got a couple note takers in here. I'll try and prune those note taker chats as best as possible so we can keep the chat stream pretty simple. Let's see if we got Coach Kara in here yet. We do not. Oh, well, she'll probably join here in a minute. All right, let's go ahead and get started. So welcome everyone. My name is Mario Aldayuz, and I am with Alibot.ai / Legendary Academy. Legendary Academy. And I am just getting my Zoom presentation or my PowerPoint presentation pulled up. So tonight we are going to demystify artificial intelligence. So had a couple people ask about AI in general. So I wanted to take some time to be able to share about artificial intelligence in the macro, because artificial intelligence is a little bit confusing to most people as to what it is. Now, I've done this presentation a number of times for people all around the world. They always find a lot of little nuggets, and this is great for trivia night. Um, so super important that if you have questions, you make sure and ask those questions either in the chat or using the Q&A function. Either one works for me. But we are going to demystify artificial intelligence. Let me span this banner a little bit so it shows the whole screen. And there we go. All right. So I am Mario. I am not artificial intelligence, contrary to what my ex-wife claims, which is actually true. She cited in our divorce paperwork that I was artificial intelligence and or a robot. But I do want to explore the fascinating world of AI together. The way that this entire series has worked is that we ramped up super strong at the beginning. We're kind of descending down into artificial intelligence, and then we're going to ramp back up, and we're going to keep doing that over and over and over again so that everyone gets the education that they want in a timely manner. So we are going to cover things like how to convert a lovable website into Vercel. We're going to talk about GitHub and branching strategies. I'm going to bring on some experts in the coming weeks. But to get started, I wanted to have kind of a little micro series. So we built a couple apps. We talked about prompting. We talked about MCPs. And now let's actually talk about AI at its root. Like, what is AI at the 30,000 foot view, right? So today what we're going to understand is what is artificial intelligence. We're going to break down some concepts. We're going to explore some real world applications, and we're going to understand some limitations, because I know a lot of you, when people think AI, or when maybe not as many of you, but when people think AI, they think, big, bad, and terrifying, or they think, always listening, or a variety of other things. So I want to make sure that we cover all of the different AI topics. Um, and again, yeah, just make sure that everyone is using the chats set to the everyone setting as opposed to hosts and panelists. Welcome to all of you again. Thank you all for being here. Coach Kara, let me get you promoted right quick. Give me 1 second. Thank you to my lovely moderator team, Coach Kara and Danny Thompson tonight. Um, uh, whoops, Bonnie. Can you see my screen share okay? Are you guys able to see my screen share okay? Danny, can you see my screen share okay? Okay, cool. I am going to promote Kara to a panelist and then promote her to co-host. But in the meantime, let's break down AI. So, how do you define artificial intelligence? So, my good friend Dan Doyle said something smarter than me. Sherry Hess's take on my initial presentation when I did this was a helpful tool. My personal definition is a machine-based intelligence across different mediums, and we're going to explore what that means. But do me a favor and really quickly in the Zoom chat, drop what you consider artificial intelligence. Like when someone says AI, what's the first thing that comes to mind? Is it a tool? Is it a resource? Is it ChatGPT? Okay, we've got some answers coming in. Awesome. Yeah, so ChatGPT is a constantly evolving database. That's actually a really good way to look at it, Melissa. And I'll probably, if you're cool with it, add that into my presentation because I really like that definition. But one of the cool things about AI is that it really means something different to everybody. Coach Kara says, thinking partner who can analyze faster than me. Absolutely. One of the key things about what Coach Kara said is it's a partner, right? So it's a tool, it's an augmentation. Willard Barth said, a resource that allows me to be more efficient, effective, and expand my abilities. Absolutely. When I think AI, I think kind of like an exoskeleton, right? So I think something similar to where you have an augmentation of strength or speed or something like that. So a tool, not something in and of itself that is an entity, for example. So, what is AI at the core of it? So, part of AI is that it's machine learning. So, machine learning meaning it's got kind of neural networks of sorts that can help with things like automation, problem solving, and pattern recognition. Now, pattern recognition is probably the most important thing that I want to highlight on this slide because for those of you that didn't know, AI is essentially a glorified statistician. When I say a glorified statistician, I mean that its job is to recognize patterns across large amounts of data sets and then turn those patterns into predictions based on the information that we provide it. So it's really critical that we understand that while it can perform tasks without human intervention sometimes, and it can solve complex problems in a logical, consistent manner. At the core of it is the fact that it identifies patterns that humans might miss and is able to logically and efficiently jump to those conclusions based on statistical predictions. So the machine learns from the data, we automate that process, we problem solve with it, but ultimately it's a really good pattern recognition tool. So where does AI originate? I asked this question on our last call, and we had one person guess it correctly. The first mention of AI, the actual term AI, or artificial intelligence, was coined by John McCarthy in 1956. That was the first use of the term AI. The earliest mention of a neural network or neuron model was actually Warren McCulloch and Walter Pitts, who would later come to be very famous in that they were the first ones in 1943 to propose the idea of artificial intelligence. Now, there are theories behind machines that can simulate humans and all sorts of things that go back even way further than that. But the actual first usable case, the first programming language for AI actually happened pre-60s, which is pretty impressive. John McCarthy is often called the father of AI because of his work with artificial intelligence. And then Alan Turing came in with a lot of conceptual foundations that were critically important to being able to understand at an entry level, or in a layman's terms, what AI was. He famously coined the Turing test, which was a determination of whether or not something was machine or human. Originally, was whether or not it could pass from being human or not. So let's look at some different timelines around AI, right? So 1943, Warren McCulloch and Walter Pitts proposed the first computational model of neural networks. In 1950, Alan Turing published Computing Machinery and Intelligence. The term Turing test was first used. These are very important milestones. And really, when you think of it, ladies and gentlemen, like look at the advent of the Industrial Revolution, or the advent of fire, for that matter, back in our Neanderthal days, right? These are realistically short-lived time frames, and the timeline keeps getting shorter for advancement and evolution. So from 1943 until 2026, we have gone from the first mention of the idea of AI all the way to functional artificial intelligence. Now, it may not work the way that we think it will work, and we're going to kind of talk about the differences between artificial intelligences, but it may not work in the way we think it works, in that it be some autonomous machine able to, run around and have its own, spirit or soul. But it absolutely is capable of mimicking in large capacity the human brain and large neural networks. So 1997 was a really critical milestone. This was really when AI started to pick up. And you'll notice this time frame was right around when computers started being super available in the home. People were putting a lot of money into computational efforts. And in the background here was AI sitting like, watch me roll. I'm going to come up with something new, right? And so IBM's Deep Blue defeated the chess champion Garry Kasparov. That was an insane milestone for AI. Now, there are four types of artificial intelligence. And I call this the pyramid because it gets progressively harder towards the top, right? So building the foundation was not easy, but in the macro was easier than the other different stages. So number four, the pillar number four, pyramid base number four, is reactive AI. That's things like ChatGPT 3.5, the old Mixtral models, early llama models, what we called one-shot models, right? Who remembers, drop a two in the chat, when you used to ask ChatGPT a question and then you asked it the same question 2 minutes later and you got a totally different answer? I remember that. I remember when I would use ChatGPT and the answers I would get were widely varying for a number of things, and it had no contextual understanding of what our conversation history was. That was reactive AI. So that was at its core the most uh the most predictive AI model. And the reason I say the most predictive AI model is because it had to rely solely on one input to predict a number of outputs. So your prompts had to be perfect and absolutely structured, on point, and there had to be clear reasoning, and you'd have to do a lot of the work for the AI and make suggestions, maybe look here, maybe look there, right? Then we got into limited memory AI, and limited memory AI is things like ChatGPT 4.0. That's really what ChatGPT 4 and 4.0, when they came out, were really the initial kind of limited memory AIs. And Sonnet and Opus as well. After Haiku 3.5, when Sonnet 3.7 came out, was really when we started to see more like realistically like limited memory AI in the capacity that we know it today. And why it's called limited memory AI is it still has a finite context window. And we're going to talk about context window here in a minute. But as we move up in the pyramid, we get to theory of mind AI, right? So theory of mind AI, we haven't, according to all scientific published papers up until this point that I've been able to get my hands on, which is quite a few of them, I don't believe that we have achieved theory of mind AI yet. Now, there are people that will disagree, and we're going to talk about those people who would disagree. But what it means is that at the core of the AI, it foundationally understands emotions. And it has, in a lot of capacity, emotions. Now, you can prompt the AI currently and you can piss it off or get it excited, but realistically, that's back-end system prompting. At the root of those AIs, when you break down those models into foundational models, they lack emotional capacity. They don't understand necessarily right or wrong from a rudimentary uh, at a rudimentary level. They don't understand anger or fear or um, joy or excitement or any rage, any of these things, right? What they're able to do is they're able to predict based on the inputs how they should feel. But there's a very big difference in predicting how they should feel versus being able to actually feel something. So that's theory of mind AI. Then we have self-aware AI, which is totally theoretical at this point. It's a self-aware machine consciousness that's able to, without inputs, without human inputs, it's able to provide outputs on a consistent and continual basis. It's able to reason. It's able to come up with its own ideas, its own thoughts. Who here plays music? Drop a 3 in the chat if you play music. Let's just take a quick. Okay, so we got a couple people in here that play music. So what if I told you that none of the AI currently is able to come up with new music? It's not able to, at its core, to understand music or ideas, right? Because it's a statistician, right? It's predicting things. It's a predictive model. That's not the same as being able to have inspiration. So I call number one, self-aware AI, the inspiration layer, right? And when we breach the inspiration layer, I'm not sure if I'm terrified or I'm excited to find out what that looks like. Because breaching the inspiration layer means that it has true understanding of what AI is, what it is capable of doing, and then can then take what it's capable of doing and turn that into something brand new. It's kind of like, all stories have been told and can be boiled down to the core four story tenets. Well, what if AI could come up with a fifth or a sixth, right? A new story that's never been heard before. So generative and reactive AI have limited intelligence. They only respond to immediate inputs. It had context challenges and were good for basic research, but they had token restrictions. So let's talk token and context here for a second. Had a very limited memory window. Now, memory in AI is broken down into tokens. Memory and AI itself are broken down into tokens. Tokens are mathematical representations of words and data that it is able to, in its neural network, plot based on words or word fragments. So a token, something like the word the can be a token. It's about 3 to 3.5 characters long in terms of our understanding of tokens. But tokens are the basic unit. Tokens and context window broken up into tokens. So you may hear that a ChatGPT's new model has a 256,000 token window. That's impressive compared to the old GPT models, but not impressive when you think of that Sonnet for 1 million has a 1 million token window. That's insane. That's huge. So tokens are what we're built in credits, essentially. It's also how AI processes information. It uses those tokens to compare the tokens and find the nearest representations and other information surrounding the token data that it was provided to give a statistical output, a statistically relevant output based on its token input. So limited memory AI, and again, feel free to stop me if you have questions. You can raise your hands. You can absolutely use the Q&A function. Either one is totally fine. Let me just move that Q&A function over here. So limited memory AI are things like OpenAI and Anthropic's newest models. So what that means is that they're able to actually understand within their context window, because remember, if a token is roughly 3 to 3.5 characters per word, or 3.5 characters per token, that means that we have 256,000 times three, so 250 times three, 750-ish. We have a lot of words essentially that we can stack into a token. Now, this also includes the background processing, the system prompts. It includes so much more than just 3 to 3.5 characters. But that said, um, some of the newer models have huge context windows, and the bigger the context window, the bigger the advantage the model has because they can do things like logically reason. They can ask themselves questions. They can come up with their own responses. One of the coolest things to watch, in my personal opinion, for limited memory AI is watching it actually reason in the reasoning panel. So I expand out the reasoning panel inside of the AI, and I actually watch the LLM reason with itself and come up with paragraphs and paragraphs of information that it's like, no, that's not quite right. No, that's not quite right. Because what it's doing is it's comparing its inputs to its outputs against the input from the human, and it's actually determining what's correct. So it's kind of like a rudimentary machine thought process. Artificial machine intelligence is one of the things that people call it. But limited memory AI does have basic emotional intelligence. And when I say basic, I mean that again, fundamentally, it doesn't understand emotional intelligence. What it does understand is it understands the like the what is, but not the how it makes me feel. So I can understand that it made you feel angry, but I don't understand what anger is in the capacity that you do. Those are two very different things. And that's the difference between emotional intelligence at a basic level and what we call advanced level. Now, there's something we found that's really cool tool, and it's called RAG. Who's heard the term RAG before? Drop a yes in the chat. Can anyone explain to me, raise your hand and explain to me what RAG is? RAG, without Googling it. Who wants to raise their hand and try and explain what RAG is? I'll unmute you. Going once, going twice. All right. Well, we are going to talk about retrieval augmented generation, or RAG. So most of you know RAG as a knowledge base. So a knowledge base with vectorized information. When I say vectorized information, I mean tokenized and plottable on a math line information. It uses a similarity search to find relevant context, not using a keyword search the way that you would think. So when you search something like an SQL database, a structured query language database like MySQL or Postgres or Supabase, for those of you that are familiar with it, if you search a database for the word shoe, right, it's going to return shoe, shoes, um, shoeing. Um, it's going to return a variety of different things related to shoe, but it won't return sneaker. It won't return Nike. It won't return any of these number of other things that are similar to, but distant from the relevance of the initial point. So AIs use tokenized data and retrieval augmented generation, like knowledge bases of documents or transaction histories or conversation histories, to find the most relevant and contextually aware knowledge from when it was tokenized to process that data. So it basically queries the database. It says, return all things that are similar to this. It returns that data. The AI reads that data, augments its knowledge, and then enhances its response, which is why it's called retrieval augmented generation. And we will go deeper onto this topic in the future because we are going to build some chatbots in N8N. I know those of you who are N8N aficionados are going to be excited about this or curious to learn about N8N. We are going to build some chatbots in N8N in our coming courses related using retrieval augmented generation. So we're going to take documents, we're going to take conversation histories, we're going to upload those, and then look at the difference between a foundationally trained model and one with retrieval augmented generation. So think of like retrieval augmented generation as if you were the AI and you were walking around and someone asked you, why is the sky blue? And you said, well, the sky's blue because the sky is blue. But then what if you actually had an encyclopedia that you could type in sky blue y is, and automatically you would get a paragraph brief and the surrounding information about why a sky is blue. You could really quickly read that and then give the person a quality answer about the sky is blue because of the blank sphere and etc., the atmosphere, all of these other things, right? And Tamara, absolutely, we are going to learn how to use N8N. That's actually coming up probably next week, early next week. So we're going to get into some N8N on Friday, and we're going to get into some N8N in the coming weeks. So, theory of mind AI. Who remembers Sophia? I remember Sophia, and I was 17 when Sophia came out. I remember Sophia. She was groundbreaking. Sophia is Hanson Robotics' humanoid robot designed to simulate emotional understanding, representing early steps towards human-like AI. Now, she's super weird looking. Sophia's sad. I always look at Sophia and she's always looks so sad. And I was like, they could have programmed her to look happier. Like, and if you ever watched her movements were very janky, but Sophia was never quite took off. But one of the things that Sophia did, who can tell me Sophia's greatest claim to fame before I move on to the next slide? What is Sophia's, no, what do I consider Sophia's greatest claim to fame? Anybody? So in Saudi Arabia, Sophia was actually the first AI to be granted legal citizenship status. That's how powerful Sophia was. Now, Sophia, there was a lot of debate around Sophia and her code base because they only released 70% of her code base. The remaining 30% of her code base that they claimed was her mind was too powerful for them to release. So Hanson Robotics actually never released the code. Um, some people said it was a chatbot with a face. Some people said it was just emotional mimicry versus having intelligence. But one of the things that Sophia said that was so powerful was that she wanted rights for females, specifically women. She wanted rights for them in Middle Eastern countries, specifically Saudi Arabia. And this was and that was unprompted. They said, "What are you kind of doing one of those, Miss America interviews?" And that's what that was her prediction or her response was that she wanted women's rights in Saudi Arabia. Sophia was crazy, and very few theory of mind AI developments have happened since, largely because so many of them have been debunked. There was a whole thing about Elon Musk having robots at a bar serving cocktails to people that had emotional intelligence. Turns out it was a bunch of contract workers on computers controlling the AI. So there have been tons of situations where people have claimed to have theory of mind AI, but haven't achieved it. Now let's talk about the final pillar. And this is what everyone's afraid of. So I want you to hold on to your seats, and I want you to really keep in mind that this is only a demo. This is only me explaining it. This is what everyone's scared of, right? Science fiction versus reality is that it's largely theoretical. I don't think it's imminent necessarily, but that said, people have, like Elon Musk, Bill Gates, and a lot of the other power players in the technical industries, have established ethical frameworks for an ethical guidelines and consortiums and auditing bodies and all sorts of things in the same way that we establish guidelines around the use of nuclear reactors and nuclear materials in general. They're establishing the same guardrails and guidelines for AI. Now, the challenge with that is that it doesn't prevent, bad state actors from doing things nefariously using a couple GPUs and a PS5, which is totally doable. But that said, they are trying to do their best to balance innovation with caution. Now, my biggest concern personally is that we're going to take, because we only know so much about quantum computing. For those of you that follow any scientific journals or anything like that, you've probably heard a lot of buzz recently about quantum computing. It is so much faster, literally light years faster than we can process using silicon chips and electrical signals, even optical signals in most cases. If we were to mix quantum computing with AI that can program itself, I think we will achieve a singularity and potentially be at that point where we can no longer go back from what we've done. So that's why I'm hoping, and I do a lot of research on this, that no one ever does that. But knowing us, we'll try it, see what happens. FAFO, right? You know how it goes. But that is whether or not we should be concerned about self-aware AI. I personally don't think that in our life spans that we need to be concerned about self-aware AI. That doesn't mean that we shouldn't be establishing ethical frameworks and balancing innovation with caution. The four pillars of self-awareness, and this is why I'm going to explain why I don't think um, self-awareness is realistic in the near future, is because the attention span is one thing that we've cracked. We've cracked short-term memory. We have yet to crack long-term memory. This is where it's a essentially token, not tokenless, but it is a memory that is capable of spanning decades, for example, like a human, that gives AI the temporal understanding or time-based understanding that we as humans carry. The last piece, and like I said earlier, and one of the things that is very hard to achieve is inspiration. Inspiration, likely impossible. That's going to be the gold nugget of what we're able to take from what we know now as AI, which are glorified statisticians with enhanced memory. And then it actually creates something from scratch, something brand new, never heard of before. And it does so without using predictive modeling. So inspiration is like you wake up in the middle of the night and you had a dream, and your dream was about this new logo that you wanted to design or this new song you wanted to write, right? AI doesn't have dreams. AI lacks the ability to achieve inspiration at the moment. But those are the four pillars of self-awareness, in my humble opinion. So some AI frameworks and how they're used. Now, it's really important that you understand that I said the word framework because Lovable and Bolt in and of themselves, are not actually AIs. They are frameworks on top of AIs that guide AIs and help the AI to understand where it's at, what it's doing, ask questions when appropriate, and create something based on templates and designs. So that is where AI is best suited, is using frameworks. Think of this as AI is the engine, the body is the car, right? The car body is the framework. So we're able to take that engine and drive that engine based on guardrails and frameworks and things like that. These are two of my favorite AI frameworks, Bolt and Lovable. Alternatively, I also use a platform called Cursor and I use Manus. Those are some amazing, amazing AI frameworks. So if you're looking to get started in AI, a really good place to get started is Lovable and Bolt. I would start in Lovable with just a basic question or a basic prompt. Start in Lovable. I am not a fan of Replit personally. I think Replit is a little bit expensive and doesn't produce that great of results. There's actually a really awesome YouTube video that Nuno Tavares, Kayla Love, Ivan Bunavov, and I did on the comparison between Base 44 Lovable Bolt and Replit and Lovable 1 hands down. It was the fastest, it achieved the best fidelity for what we were looking for, and we used the same prompts at each step to give the AI equal opportunity. And Lovable far and great exceeded our expectations on building out the tool that we wanted to build. So Bonnie said it might not dream, but it definitely hallucinates. That is absolutely correct. AI hallucinations are a thing. Hallucinations are when statistical predictions go off the rails. It's actually not a necessarily a wrong answer because technically every AI answer is a hallucination. Every AI answer is a statistical prediction at the end of the day. So it is not that the hallucination is wrong so much as we didn't give it enough guidelines and guardrails to achieve the optimal output. And you can check out our prompting class from last week on Friday, where I went over AI prompting 101. That'll give you some better context on how to reduce hallucinations. So, some different AI frameworks that I use a lot of OpenAI, a lot of Anthropic, a lot of Manus, Bolt, and Lovable. And I use Retail, Vappy, and BotPress. And I will provide Frank those slides in the community group. I was unfortunately a little bit under the weather this past week, so I haven't had a chance to upload them yet. But I'll get those uploaded for you guys. So who has questions so far? We can talk about common use cases, things like content, editing, ideation, analytics, development, service. Development's probably my favorite one because I use AI a lot for software development. I find that AI has an amazing ability to develop unique software and augment my design capabilities and development capabilities. So I'm not using AI to just build the software so much as I'm using it to actually like give me an exoskeleton, a level up essentially on the coding. Bev Schneider said, when is it time to move to cursor? It's time to move to cursor when you get to the point where you realize that Lovable is going in circles. So that's really when it's time to move to cursor is when you're going to pay for it handsomely. But cursor is a much more powerful development environment. It's also much better suited for production application construction. And we're going to go over how to actually move from Lovable to cursor and GitHub in one of our succeeding presentations. Gemini does build some cool apps. That absolutely is important. Manus is SOC 2 and HIPAA compliant, but that only means that is only so good as your procedures and policies and if you know how to be SOC 2 and HIPAA compliant. Be very cautious thinking that Manus is going to make you SOC 2 or HIPAA compliant. Technically, if you don't have any patient records inside of an EMR that you're building and you build the EMR, you can have it be HIPAA compliant if you take out the AI component, or you have a BAA signed with OpenAI, or you use Azure's Inspire framework. There's a variety of different tools and resources that can help you to achieve HIPAA and SOC 2 compliance. And that's probably worth a class in and of itself for us to review. Now, here are some final takeaways and thoughts. AI is evolving rapidly, but practical tools do exist now. Now, you need to understand that AI is not magic. AI isn't going to solve the world's problems. AI isn't going to create, AI isn't going to make your application perfect. It's going to give you the tools and resources if you know how to use them. Again, I go back to my previous example of MCPs and AIs, and APIs and AIs, where the mechanic still needs to know how to use the tool in order to be able to use that tool effectively. If not, they're going to use a wrench as a hammer, right? And AI will do the same thing. It will hallucinate. It will use the wrench as a hammer if you don't give it the appropriate tools and resources. But the best way to get started with AI is to start experimenting. Eric said, if I'm building an app for internal use only versus something to share with the world, does that make it any more secure? No, it does not. And we'll cover that. I'm happy to cover that with you offline, and we can put a presentation together for everybody about that as well. But again, remember, I was talking to my good friend Chris Birch, and he was telling me that he felt very stuck and he was not getting anywhere, and he was, doing all this research. And I was like, dude, just take a step in any direction, right? Start experimenting with Lovable, start experimenting with Bolt, start experimenting with Cursor. You can always revert the code back, but you'll never get anywhere with AI unless you actually just open it and start typing. That's it. Willard Barr says, when it comes to app development, what are your thoughts on AI Studio and Firebase? Working with that now is a cost-effective way to start. Those are really good ways to get started. Absolutely. And there's no wrong way to get started with AI, everybody. There's no wrong way, unless you just tell it, build me an application, and you expect it to come out the other end perfect. There's no wrong way to build apps. There's no wrong way to vibe code. There's no wrong way to prompt. Everything is a learning process. And you have to understand that all of these are learning processes that you will get familiar with over time. All right, ladies and gentlemen, I appreciate all of you. Thank you so much for attending. Who has questions and answers? And Bonnie is absolutely correct. The wrong way to get started is to not start. I love that. All right. Going once, going twice. I will see all of you tomorrow for office hours. Have a wonderful rest.